Numerical number 5, relative velocity. Numerical number 5. Rain is falling vertically with a speed of 30 meter per second. A woman rides a bicycle with a speed of 10 meter per second in the north to south direction. What is the relative velocity of the rain with respect to the woman? What is the direction in which she should hold her umbrella to protect herself from the rain? According to the question given, velocity of the rain, that is Vr, is equal to 30 meter per second, and velocity of moment Vw is equal 10 meter per second. 10 meter per second due south. That means the woman is riding her bicycle in north to south direction, and we have to find vrw, that is relative velocity of rain with respect to woman. And what about the direction of fall of rain? In this case, vr is equal 30 meter per second. Along this direction rain falls, that means rain falls with a velocity vector Vrm in vertically downward direction, and this is the woman who will be riding her bicycle from north to south direction. This is a woman, and this woman is riding her bicycle with the velocity vector Vw. This is the direction along which rain falls. That means rain falls vertically downwards with the velocity vector Vr. And we can denote south direction, and vertically downward rain falls vertically downwards with the velocity vector Vr, and this is north direction, and the woman is riding her bicycle from north to south direction with the velocity vector vw. Vector vw is the velocity vector of the woman due south. Now the relative velocity of rain with respect to the woman. The relative velocity of rain with respect to the woman on her bicycle is given by vector vrm is given by vector vrw is equal to vector vr minus vector vw. Vector vrw is equal to vector vr plus minus vector vw. We can extend the velocity of rain in vertically downward direction more, and this is the ground on which the woman is riding her bicycle. For vector vrw, as minus vector vw is added with vector vr, we should denote minus vector vw. Minus vector vw is negative of velocity of woman due north. Minus vector vw is due north, and we have to add vector vr and minus vector vw, and this is the direction along which the resultant of vector vr and minus vector vw is acting, and this resultant is vector vrw. Vector vrw is the apparent velocity of rain with respect to woman. Here the rain will appear to come from this direction with the apparent or relative velocity vector vrw. Vector vrw is the apparent velocity or relative velocity of rain with respect to woman due to its relative motion. This is the now rain is actually falling vertically downwards, but it will appear to come from this direction. As rain will appear to fall from forward direction at an angle phi south of forward direction. That's why the woman should hold her umbrella along this direction. The woman should hold her umbrella along this direction at an angle phi south of forward direction. This is the umbrella which will be used by the women. Now vector VRW makes an angle phi with vector VR. That means the relative velocity of rain with respect to women, that is vector VRW, is at an angle phi with the vertical direction. That means vector VRW is at an angle phi north of vertical direction, north of vertical direction. As vector VRW equal vector VR plus minus vector VW, that's why mod vector VRW is equal root over VR square plus VW square minus 2 VR VW cos theta, minus 2 VR VW cos theta. Magnitude of here, this is the angle theta, and theta is the angle between vector VR and vector VW, and we know that theta is equal to 90 degree as rain falls vertically downwards and woman is riding her bicycle due south. That's why theta equal 90 degree, which is the angle between velocity of the rain vector VR and velocity of the woman vector VW. So we get VRW as equal root over VR square plus VW square, which is equation 1. Let vector VRW acts at an angle phi. Vector VRW acts at an angle phi with the vector VR. That means the relative velocity of rain with respect to vector VRW acts at an angle phi with the vertical direction, that is with the direction of fall of rain, or with the direction of fall of rain with velocity, with the direction of fall of rain with velocity, with the velocity vector VR equal root over 30 square plus 10 square. VRW will be equal to root over 30 square plus 10 square equal root over 1000. Therefore, therefore VRW is equal 10 root 10. 10 root 10, that is 10 into 3.16. Therefore, VRW, that is the relative velocity of rain with respect to women, is equal to 31.6 meter per second. Vector VRW acts at an angle phi with the vertical direction, that is with the direction of fall of rain with the velocity VR. Therefore, tan phi is equal mod minus vector VW sine 180 degree minus theta, 180 degree minus theta. Now we can denote the angle theta. Theta is the angle between vector VR and vector VW. Theta is equal to 90 degree, which is the angle between the velocity of rain vector VR and vector VW. Vector VR is the first vector which makes an angle phi with the vector VRW, and divided by mod vector VR plus mod minus vector VW cos 180 degree minus theta equal VW sin theta divided by VR minus VW cos theta. Now putting the value of theta, we get VW sin 90 degree divided by VR minus VW cos 90 degree. Therefore, tan phi is equal to VW by VR, since sin 90 degree is 1 and cos 90 degree is 0. Tan phi is equal to VW by VR, that is tan phi is equal to velocity of woman divided by velocity of rain, or comma phi is equal to tan inverse VW by VR. Phi is equal to tan inverse VW by VR, or comma VW phi is equal tan inverse 10 by 30. Phi is equal to tan inverse 1 by 3. Phi is equal tan inverse 1 by 3. Therefore, the value of phi will be 18.4349488.2 degree. Phi is equal to 18.4349488.2 degree. That means this phi can be expressed in terms of degree, minute and seconds. Therefore, phi equal to 18 degree 26 minutes 5.82 seconds. We can denote vertically opposite angle as phi in the diagram. then we can say that the relative velocity of rain with respect to the woman, the relative velocity of the rain with respect to the woman is given by VRW as equal 31.6 meter per second. Also the woman has to hold her umbrella. The woman has to hold her umbrella at an angle of phi equal 18 degree 26 minutes 5.82 seconds with the vertical direction towards south at an angle phi equal 18 degree 26 minutes 5.82 seconds with the vertical in the direction of her motion, that is towards south. That means if we assume that the woman is riding her bicycle from north to south direction and south is the forward direction, then woman has to hold her umbrella at an angle phi equal 18 degree 26 minutes towards south in forward direction, towards south, that is in forward direction, and phi is the angle with which the woman has to hold her umbrella in forward direction, that means towards south with respect to the vertical direction.